Hey everyone, welcome to this course. In this course, we will be exploring a wide variety of data science techniques in the Wolfram language through a plethora of examples ranging from chemistry to linguistics. The goal of this course is to introduce you to the power of the Wolfram language in completely transforming how you do data science. With that in mind, let's explore the core object at the heart of our course, the entity. This is where most of the curated data in the Wolfram language comes from. There are tens of thousands of these entities in the Wolfram language. They correspond to people, countries, chemicals, and almost anything you can imagine. There are even entities for Pokemon. Let's take, for example, the entity corresponding to the United States. What we can do is use Control plus equals and type in our desired entity. This method of typing free-form expressions in and getting precise Wolfram language ones back is very important and something that you will use often when you don't know how to specifically access some data. After we do that, we can confirm that the outputted expression is what we wanted. And voila, we have this entity object right here. Applying / input form, which is a postfix form of applying a function, onto our entity to find what input we needed to write to get it gives us the following result. We find that it's the entity function, with the first argument being the type of entity, in this case country, and the second argument being the actual entity name, in this case the United States. We can copy and paste this expression into a new input cell and evaluate it to test it, and we get the same entity back. With each entity class comes a plethora of properties. Some entities have hundreds of properties, and some only have a dozen or so. But our country entities are one of the most well documented. The way we can access those properties is by directly calling them in brackets after our entity. The / shallow is a postfix form of applying shallow, a function which only gives you the first elements of a list to save up on notebook space. From the first elements alone, we see a wide range of properties that we have on the United States. We can also directly call the properties of the entity type as they are uniform within each entity type. Using the entity property function on the entity type country gives us the same results. Let's get some data now. We can copy and paste properties into brackets after our entity to retrieve our data. In this case, we will get the United States adult population, which turns out to be over 213 million people. We can also just directly type in the name of the property we want, in this case adult population, and get the same result back. Notice that all of these entity objects, including properties, have direct input forms. As always, you can apply the input form function to find out what that input form is. Okay, now we know how to get current data. But what about historical data? The dated function is here to help. It helps you access data at any time in the past, given that that data is available, or any range of dates that it is available in. You can apply it directly on the entity. For example, here I am applying the dated function and indicating that I want the date 2000 for my entity United States. Now, whatever property I call after, I will get its value in the year 2000. Calling the adult population property gives us over 186 million adults. There is another way to input this. We can also apply the dated function directly on the property, and once again indicate we want the year 2000. This gives us the exact same number. The way we can get all historical data is pretty intuitive. Simply substitute in that year for all. This outputs the following time series. These time series are simply special lists of data in which x values are date objects that we can easily do operations on like subtraction. We can visualize this data by applying the datelistPlot function, which is how we plot time series. All of this is pretty cool stuff, but if we want to do it at a larger scale, we will need the entity value function. This function makes retrieving multiple properties, the properties of multiple entities, and getting associations very easy. We'll see how in just a second. First, let's simply take the adult population again. As you can see, it's pretty intuitive. Simply put in the entity first and the property you want second. If we want to retrieve both the total population and the adult population, we will simply put them both in a list after the entity inside our entity value function. This outputs both quantities. We can also get the adult population for two or more entities, in this case the US and China. As you can see, it's a pretty neat function that takes care of more complex tasks. So what if you have a lot of entities and you want to be able to see which data corresponds to which entity? Simply tack on that you want an entity association at the end of your entity value. This ends up associating the properties you called with their entity. These associations are something very important that we will use often as we progress through the course. They are indicated by arrows. The object before the arrow is called the key. Think of it like the key to access the precious data. The object after the arrow is called the value. This is where you usually store your data. What if you have a bunch of entities and also a bunch of properties that you're calling? Well, just put in that you want an entity property association. This not only associates your entities with the data, but associates the properties with their values. This way, you can make sure you never lose track of which data is which. There's also a neat way to do operations on the data that you retrieve. For example, to find what percentage of the US population are adults, we have to divide the adult population and the total population. The way to do this easily is through entity function inside an entity value. After putting our entity in, we say that we want an entity function for an arbitrary entity I that takes its adult population and divides it by its total population. We get that it's about 65%. The abstract variable I is there such that we can apply it to not only the US, but multiple entities if we need to. Let's test that it works by putting in China there too. Applying the same code but adding entity association at the end to not lose track of the data, we see that our entity function indeed works and shows us that China has a higher adult percentage. Before moving on to another important topic, here is the list of all entity types. As you can see, there are hundreds of them. You can explore this page in more depth to see which data is available to you directly through the Wolfram language. Back to our notebook now. The last thing we'll explore in here will be the concept of an entity class. These entity classes are subclasses of broad entity types. You can either make your own based on any criteria in the data, or you can check out some of the entity classes that are built in into the Wolfram language. The way to call these built-in entity classes is through the entity class function. In here, we'll call the entity class Europe in the entity type country. This, as you guessed it, gives us the class of all European countries. We get this entity class object back, and to actually get the list of entities, we will need to apply the entity list function on our class. As you can see, we get back the list of all countries in Europe. We don't need the entity list to be able to work with the class, however. We can directly work with it. For example, let's check something trivial. Is Pakistan in Europe? We can apply the GeoWithinQ function, which tells us whether a geographic region is within another, to obtain that the answer is indeed false. We can also directly get a property for all entities inside an entity class. The way to do this is pretty intuitive. Just place the entity class as the first argument in the entity value function, call the property you want, in this case population, and then indicate that you want an entity association so you don't lose track of which data is which. We can visualize this through a function called GeoRegionValuePlot, which basically plots a heat map of different regions. We will explore much more data visualization functions in the next video and touch on their usefulness. You might notice this piece of code right here. This is what we call an option. Options, in the case of visualizations, are mostly there for stylistic purposes, and we will explore them in more depth in the next video. As you can see, we get this nice plot back showing us the population by country in Europe. You might wonder what entity classes there are. You can find out by calling the property entity classes for a particular entity type. As you can see, we have hundreds of such entity classes for countries. We can get a random sample out of this data using the random sample function. The double brackets with the 1 inside are simply there to get rid of the unnecessary layer of listing. We get the following entity class. We can visualize this entity class using the geographics function. Inside our geographics function, we'll indicate that we want a black edge polygon on the previous output, indicated by the percent symbol. We'll also set our georange as the world. We see the following neat visualization. We can find how many entities were in the previous entity class by using the entity count property. Here, the double percent symbol indicates 2 outputs ago. What's really neat about entity class is that you can define your own classes. For example, say you want the 10 countries with the largest borders. You can indicate that for your entity type country, you want to take the largest 10 in terms of full boundary length. You can apply entity list on this class to get the following list of countries. You can also set constraints on the values of your properties. Let's say we'd only like countries with a population between 10 million and 50 million. We can do that by simply indicating for the property population, we only want between 10 million and 50 million people. The rest is similar to what we did before, simply applying a black edge polygon onto this entity class, which gives us the following neat visualization. That was quite a lot of information to take at once. But don't worry, we'll always go step by step in this course. We'll make sure to introduce any new functions before applying them and also repeatedly stress the why behind what we're doing. As we just explored, the concept of entities can revolutionize how you do data science. Since all this data is localized, clean, and robust, you can do quite a lot even with little experience. See you in the next video on the visualization capabilities of the Wolfram language.